With a basic knowledge of the Paylomatic system, we can now discuss a systematic procedure for isolating and correcting specific operational problems. But remember, there's much work to be done before the serviceman opens his toolbox and goes to work on a Paylomatic system. The work begins when the customer calls your shop. Use the telephone effectively. Don't let the customer simply say that his machine isn't running right. Be familiar enough with the common problems of the Paylomatic system to ask the customer specific questions about the machine's performance. With this information, you should have a fair idea as to the cause of the problem and what components will be required to repair the machine. In the way of special tools, pressure gauges with a 1,000 psi and a 3,000 psi capacity respectively will be required. Take along some quick disconnect fittings too. Also, engine diagnostic equipment is required in some instances. If available, an hydraulic flow meter can be used to good advantage. If a flow meter is to be used for pump and valve checks, make certain that proper fittings and jumper hoses are available. One more point. In most instances, a bad pump, control valve, drive motor, or solenoid valve can be repaired. However, the customer's machine may be back on the job sooner if replacement components are installed in the field and the old parts then reconditioned back at the shop. The format of this problem diagnosis section is as follows. The drive system problem is stated, such as no drive. A testing procedure is then discussed for each of the probable causes, starting with the most simple checks and progressing to the more difficult. If, when checking the probable causes, a faulty component is isolated, that part should be removed for repair or replacement and the machine tested. If the problem is completely corrected, there is, of course, no reason to make the remaining checks. The first problem to be discussed is a lack of power or low speed in all transmission ranges. This problem is the most difficult to diagnose in that there are no specific indicators as to its possible cause. Thus, the entire hydraulic portion of the drive system must be checked. However, when low power or low speed is the operator's complaint, first check engine performance. A poorly tuned engine or an engine with mechanical problems could account for the low power, low speed problem. This illustration shows a typical tachometer hookup for gasoline engines. For diesel engines, secure the proper test equipment. Engine spec details are included in the addendum. If engine tests indicate poor engine performance, refer to the appropriate engine service manual for necessary testing, adjusting, or repair procedures. An improperly maintained reservoir might be the cause of the low power, low speed problem. Check that the reservoir is filled to the proper level with the correct type of fluid. Check that the vacuum valve is operating and that the breather is clean. Inspect the pump inlet strainer and clean if necessary. Make certain that the supply line from the reservoir to the pump is not internally damaged. The main relief valve can cause low drive system pressure if it is improperly adjusted. Pressure should be set between 2,400 and 2,600 psi. Use the following procedure to check main relief valve pressure. Place the machine on flat level ground. Lower the bucket to the ground. Place the transmission control lever in neutral. Apply the parking brake. Place blocks in front and back of both drive wheels. Remove the seat. Install a pressure gauge of 3,000 psi capacity in the small pumping element inlet elbow at the transmission control valve. Start the engine. Place the selector lever in F1 or R1. Accelerate the engine. The pressure should build to 2,400 to 2,600 psi. If the pressure is too low, less than 2400 psi, remove the hose at the detent end of the control spool and the plug holding the high-pressure piston in the relief valve cylinder. Remove also the small spring, high-pressure piston, shims, if present, and the relief valve spring. If the high-pressure piston was difficult to remove, or if either spring is broken, remove the complete control valve for repair or replacement. If the high-pressure piston was removed easily and the springs were not broken, it is possible the main relief valve spring has taken a set that necessitates adding shims to increase system pressure. Add the appropriate number of shims to increase system pressure to 2400 to 2600 psi. Each shim has a value of approximately 100 psi. Recheck the pressure setting. If pressure is not increased approximately 100 psi for every shim added, the main relief valve could be sticking. Repair or replace the control valve. Insufficient flow from the transmission pump could account for the low power, low speed problem. If an hydraulic flow meter is not available for checking pump flow, the pump may now be replaced. To test the transmission pump, both elements must be checked individually with a flow meter. To check small element flow with an inline flow meter, disconnect the small element delivery hose at the control valve. The thread size of this valve port is 1 1/16 by 12. Use an adapter to connect this hose to the inlet port of the flow meter. Connect an additional hose, comparable in quality and size with the pump hose, between the outlet port of the flow meter and the control valve port. Start the engine, and with the transmission in neutral, make the following checks. Engine at high idle, 0 psi pressure. Engine at high idle, 1250 psi pressure. Engine at high idle, 2250 psi pressure. In each of the above checks, pump flow should be approximately 16 GPM. A severe drop in flow between the 0 psi test and the tests under pressure indicates a pump malfunction or possibly an internally damaged delivery hose. Remove the hose between the small pump element and the flow meter and inspect it for internal damage. If the hose is not damaged, repair or replace the pump. To check large element flow, disconnect the large element delivery hose at the control valve. The thread size of this valve port is 1 5/8 by 12. Use an adapter to connect this hose to the inlet port of the inline flow meter. Connect an additional hose, comparable in quality and size with the pump hose, between the outlet port of the flow meter and the control valve port. Start the engine, and with the transmission in neutral, make the following checks. Engine at high idle, 0 psi pressure. Engine at high idle, 1250 psi pressure. Engine at high idle, 2250 psi pressure. In each of the above checks, pump flow should be approximately 76 GPM. A severe drop in flow between the 0 psi test and the tests under pressure indicates a pump malfunction or possibly an internally damaged delivery hose. Remove the hose between the large pump element and flow meter and inspect for internal damage. If the hose is good, repair or replace the pump. If pump flow was up to specs, or if replacement of the pump did not correct the problem, the control valve could be leaking internally. If a flow meter is not available, the control valve may now be replaced. To check the valve for internal leakage with an inline flow meter, disconnect the forward and reverse motor supply hoses from the control valve. The thread size of these ports is 1 5/8 by 12. Cover the ends of the disconnected hoses to prevent contamination. Using 2 jumper hoses equipped with proper fittings, connect the forward motor port to the inlet port of the flow meter and the reverse port to the outlet of the flow meter. Start the engine and move the transmission control lever to the F1 position. Accelerate the engine to high idle and adjust pressure at the flow meter to 2250 psi. Flow should read approximately 16 GPM under these conditions. If flow is severely below 16 GPM, repair or replace the control valve. If checks up to this point have revealed no faulty components, either the drive motor supply hoses or the drive motor itself is the problem. Remove the hoses and inspect for internal damage. If the hoses are okay, then the problem is in the drive motor. In the no drive condition, the machine will not operate in any transmission range, although engine speed is high enough to open the micro switch. A probable cause for the no drive problem is a closed micro switch. If the micro switch is stuck closed, electric current will flow through the switch and energize the solenoid valve, thus preventing oil flow to the high-pressure piston. Determine if the micro switch is the cause of the problem with the following procedure. Turn on the ignition switch, but do not start the engine. The disconnect light should go on with the ignition switch and should go off when the accelerator is depressed. If the switch functions properly, proceed to the brake pressure switch check. However, if the disconnect light does not go off when the accelerator is depressed, remove the wires from the switch. If the light goes off, replace the micro switch and retest. If the disconnect light remains on when the wires are disconnected from the micro switch, the brake pressure switch is stuck in a closed position. Replace the brake pressure switch. Test the brake pressure switch as follows. Turn on the ignition switch, but do not start the engine. Depress the accelerator to open the micro switch. With the accelerator held depressed, step on the brake pedal. The disconnect light should go on with the application of the brake. If the disconnect light does not go on, replace the switch and retest. If the micro switch and brake pressure switch check out okay, the problem could be in the solenoid valve. To check the solenoid valve, disconnect the 2 wires attached to valve from the loom leads. Install a jumper wire into each valve wire. Ground one of the jumper wires to the frame and touch the other to the positive battery post. If the solenoid is operating properly, a slight click can be heard as the coil energizes and unseats the plunger. As a double check, place your hand on the coil housing and sense the movement of the plunger. If no movement of the plunger is detected, repair or replace the solenoid valve. An open main relief valve can cause the no drive condition. The valve might be stuck in an open position, or perhaps it is not being properly closed because of a broken spring or a sticking high-pressure piston. If the micro switch, brake pressure switch, and solenoid valve function properly, replace the control valve. If, however, replacement of the control valve does not correct the problem, check the reservoir, pump, and drive motor as outlined in the previous problem. If the replacement valve corrects the no drive condition, pressure check the main relief valve and adjust if necessary. If the machine drives normally in one direction but will not operate in the opposite direction, this indicates that oil flow to one side of the drive motor is being restricted. The problem is most likely caused by a faulty check poppet, but also could be the result of a damaged motor supply hose. Check the hoses for internal damage. If the hoses are okay, repair or replace the transmission control valve. If the drive system does not disengage or disconnect, the engine will stall when the accelerator is released or the brake pedal applied. A probable cause for the no disconnect problem is an open micro switch. If the switch is stuck in the open position, electric current cannot reach the solenoid valve when the accelerator is released. With the solenoid not energized, oil flow will keep the main relief valve closed and the drive system engaged. Determine if the micro switch is good simply by turning on the ignition switch. If the disconnect light does not go on, replace the micro switch and retest. The brake pressure switch, if stuck in the open position, will have the same effect on the system as a bad micro switch. Check the brake pressure switch as follows. Turn the ignition on, but do not start the engine. Depress the brake pedal while holding the accelerator depressed. If the brake pressure switch is good, the disconnect light will go on with the application of the brake. If the disconnect light does not go on, replace the switch and retest. If the micro switch and brake pressure switches were good, the solenoid valve might be causing the problem. Use the procedure previously discussed to check solenoid valve operation. If no movement of the solenoid plunger is detected, repair or replace the valve. No problems revealed up to this point indicates that the main relief valve is either stuck in a closed position or is not being released because of a faulty high-pressure piston. The control valve should now be repaired or replaced. If the machine functions normally in F1 and R1, but lacks speed in F2 and R2 because no automatic upshift occurs, oil flow from the large element of the pump is not reaching the drive motor. The no upshift problem is caused by the large element unloading valve being in an open position, due either to misadjustment or malfunction. Use the following procedure to check the large element unloading valve pressure. Place the machine on flat level ground. Lower the bucket to the ground. Place the transmission control lever in neutral. Apply the parking brake. Place blocks in front and back of both drive wheels. Remove the seat. Install a pressure gauge of 1,000 psi capacity in the large pumping element inlet elbow at the transmission control valve. Start the engine. Place the selector lever in F2 or R2. Accelerate the engine. The pressure should build to 750 psi minimum, 800 psi maximum, then drop to reservoir pressure. If the pressure is too low, less than 750 psi, remove the cap screw in the plug above the eye end of the control spool and add the number of shims necessary to increase the pressure to 750 to 800 psi. There are two sizes of shims to make this adjustment, a 30 psi shim and a 10 psi shim. If the pressure is too high, greater than 800 psi, remove enough shims to lower the pressure to 750 to 800 psi. If readjustment of the valve does not correct the problem, repair or replace the control valve. With a no downshift problem, the engine will lug down severely when the machine is operated in F2 or R2 and there is a need for more power. A probable cause of no downshift is an open mixing valve. To check mixing valve operation, remove the plug, spring, and poppet. Check for contamination or a broken spring. Inspect the poppet seat for nicks. If the mixing valve is faulty, repair or replace the transmission control valve. If the mixing valve is good, the large element unloading valve is most likely in the closed position, due either to misadjustment or malfunction. Use the procedure previously outlined for checking the unloading valve pressure. If the unloading valve pressure is not within the specified 750 to 800 psi range, readjust the valve. If readjustment does not correct the no downshift problem, repair or replace the control valve. This completes our discussion of the most common Paylomatic drive system problems. Following the procedures outlined should result in more efficient use of your time and in less downtime for the customer. Remember, learn all you can about the problem when the customer calls. Take along the components and tools that are required, and think about the diagnostic approach you'll take before you begin work.